Hello everyone, welcome today to this pHix-up program. I am Aurore Courillon, product manager at Timab Magnesium here in France, and I am very pleased to welcome you today. For 1 hour, we will discuss about pHix-up, coming back on our product's technical characteristics and specificities, and talking about its result from the research side, but also on the field to help farmers to improve performances. So to help me today, let me introduce you Mélodie Baudon. Hello Mélodie.
Hello Aurore and hello everyone. I am Mélodie Baudon. I am also product manager as Aurore at Timab Magnesium, and I'm really happy to be here today to discuss with you about pHix-up.
So today we will have the great pleasure to welcome a few guests who have been working with us on pHix-up. So Professor Marcos Neves Pereira, Associate Professor at the Zootechnical Department of Universidade Federal de Lavras in Brazil, Dr Alex Bach, Professor at the Catalan Institute Research and Advanced Studies, and at the Department of Ruminant Production of Institute of Agri-Food Research and Technology in Spain. And also Javier Viejo, Technician Veterinarian at Tecnivet in Spain. So before we welcome our guests, let me remind you that you can send us your question in the chat box on the right side of the screen. So Mélodie, now let's have an insight into pHix-up. So, Mélodie, first important question, what is pHix-up?
Yes, so pHix-up is an innovative nutritional solution that was developed by Timab Magnesium in 2017. The aim of this product is to act directly on rumen pH by neutralizing the excess of acid. And you can wonder, why is it different from the other solution on the market? It's different because pHix-up is the only product to have a powerful action, a high neutralizing capacity, and a fast and long-lasting action in the rumen.
Okay, Mélodie, and what's the background of pHix-up to reach that specific characteristic?
Yes, so pHix-up concept has been developed thanks to Timab expertise on magnesium and thanks to Timab industrial know-how. There were specific magnesium oxide sources that were selected for this product, and these magnesium oxide sources were especially chosen to have a complementary action on potency and kinetic. And thanks to this, we can guarantee an optimal pH in the rumen. And that's actually why pHix-up is so specific. So what I propose you now, Aurore, is to have a quick look on the following video to know more about pHix-up and its specificity.
As we know, rumen of lactating cows can be challenged, and this can lead to an accumulation of acids in the rumen and to the decrease of the rumen pH. pHix-up, included in the diet, has a strong neutralizing capacity, helping to increase quickly the ruminal pH and bring back the pH to an optimal and physiological level during several hours. With a higher neutralizing capacity, up to 39 milliequivalent per gram, a fast and long-term kinetic, pHix-up is the best solution on the market to act directly on rumen pH and stabilize rumen environments.
Okay, so thank you, Aurore, for this video. And can you tell us who are the pHix-up users?
Yes, so pHix-up is intended for those farmers who are looking for a certain level of performances without compromising the animal welfare and health. So pHix-up concretely can be used for lactating cows fed with high energy concentrated rations directly on the farm in the total mix ration or through the complete feed at the feed miller level. So pHix-up users are looking for a breakthrough innovative solution bringing added value for rumen management with more efficiency and reliability.
Okay, and what are the proofs of the efficiency of pHix-up today?
So pHix-up history actually starts in 2015. To develop pHix-up, we needed two very important factors. So first, we needed the Timab Magnesium expertise to screen sources, and second, we needed the research capacity of the Roulier Group, the World Innovation Center here in France, to generate multiple in vitro tests. Indeed, we use in vitro rumen fluid systems to screen sources and develop pHix-up. In a published meta-analysis, including 28 comparative in vitro tests, we confirmed that pHix-up has the most powerful effect on pH compared to common buffers and buffer mixes.
Yes, so that's really interesting, these results. And what did you exactly conclude for pHix-up with these results?
So we showed that pHix-up is the only product to combine a powerful, fast and persistent action. And we also showed that pHix-up shows a linear dose response with a lower dosage than sodium bicarbonate, putting some space in the ration. So all those results have been published in the Journal of Dairy Science in 2018. So pHix-up is showing a powerful action in vitro, but now let's focus on how the product performs in vivo. So on the field, we followed 12 different trials in different countries around the world using ruminal pH boluses and including more than 10,000 cows. So Melody, can you tell us a little bit more about these studies?
Yes, absolutely. So in 2020, we made a meta-analysis with some of our trials with pHix-up compared to previous buffers. These trials are based in many countries as USA, Chile, France, Netherlands, and Italy. And these countries represent all the different areas with different level of concentrate, so from 30% to 50% in the diet. And we measured the ruminal pH with intraruminal boluses, so that's what you can see on the graph. And in green, it's pHix-up. So what you can see is that pHix-up, with pHix-up, you have less time below pH 5.8, and the coefficient of variation is lower. And this better rumen environment leads to an increase of some production parameters. The results presented in this table are based on the milk tank data. That's really interesting because that's on these production parameters that the farmer will be paid. And in average, we observed that with pHix-up, the level of milk yield will increase by 1.2 kilograms per cow per day, and the level of fat will increase by 50 grams per cow per day, compared to the previous buffers. And today, pHix-up is included of the diet of more than 300,000 cows and in 30 countries. As you can see on the map, diets are really different regarding the different countries, and this leads to a different risk of acidosis. So pHix-up is definitely field-proven.
Thank you very much, Melody. So pHix-up is definitely efficient to manage rumen pH and improve performances for lactating dairy cows. So let's now welcome our guests to talk about their experience with pHix-up. Now, let's welcome Dr. Alex Bach, who is professor at the Catalan Institute of Research and Advanced Studies and at the Department of Ruminant Production of Institute of Agri-Food Research and Technology in Spain. So, hello, Dr. Alex Bach.
Thank you for the invitation. It's a pleasure to be here.
So, first question, why do you think it is important to work on ruminal pH?
Well, rumen pH is probably the paramount topic in rumen nutrition, right? In ruminant nutrition. Actually, cows consume acids. Basically, they transform what they consume, which is forages and concentrates, into acids. So if there is an excess of accumulation of those acids in the rumen, we'll have rumen acidosis, which is the most common problem in dairy nutrition and also in beef cattle as well. If you look in the slides on my site, you can see that there's a balance in the rumen pH that is dictated by how much acid is being produced from the fermentation. These are bacteria at work. And thanks to these bacteria, cows are able to transform forages and concentrates into milk. So we want these actually acids being produced in the rumen. So we're always in this balance between having lots of acid being produced and that acid being removed or neutralized in the rumen. So that's why it's important that we understand and we know how to modulate that rumen pH, because we actually want to maximize those acetic acid, propionate acid, butyric acid, which are the building blocks for milk and reproduction and disease fighting, with an excessive of accumulation of hydrogen ions in the rumen. So from a nutritional perspective, what we feed to the cow will have an influence on that pH. And we're always balancing, okay, how much fiber we're going to put in the diet. We think of fiber as something that will not create acidosis. I think that's a little bit mistaken. And also how much starch or non-fiber carbohydrates we feed to the cow. So basically what drives that rumen pH down is the amount of non-fiber carbohydrates that we feed. And it's amount and not percentages. So we need to understand all these factors to really modulate the pH in the rumen. If the pH goes out of balance, then a lot of bad things will happen to the cow.
Okay, great. So what are the physiological impacts of low ruminal pH for dairy cows, and what are the consequences?
Right, that's a very good question. And because, as I said before, rumen pH is so pivotal in the physiology of the animal, any change in that rumen pH will have consequences in different aspects of physiology at two levels, at the rumen level and also at the host level or at the cow level. At the cow level, the first thing that we'll see and will happen is that she will attempt to modulate that rumen pH. In the same manner that animals control blood pH, cows and ruminants in general, they will also have some mechanisms to control that rumen pH. So the first thing that the animal will do is actually shut down intake. Will have a decrease in appetite. Because if they ingest less carbohydrates, chances are that there will be lower fermentation in the rumen and then lower production of acids. On the second part, so the other aspect of a change in rumen pH or a low rumen pH will be directly on the microbial population in the rumen. In the rumen, we have several types of microbes. We have protozoa, we have fungi, we have bacteria, and not all of them have the same sensitivity or tolerance to rumen pH. And in fact, if you look at gram-positive or gram-negative are a little bit more sensitive, the ones that live in the rumen, to low rumen pH. And these guys will start first shutting down their activity. So if they are involved in fiber digestion will be compromised as rumen pH goes down. And if rumen pH goes even lower, then these gram-negative bacteria will actually die. So physiologically, what we see is as rumen pH goes down, there is a shift in the microbial population. There is an increase in gram-positive and a decrease in gram-negative. And also there is a change in the physiology of the rumen per se. So there is a decrease in digestion capacity and rumen function in general. So basically what the most important aspect is that fiber digestion will be decreased.
Okay, very interesting. Is there any consequence regarding disease such as lameness, bloat?
Right, of course. If something that important as rumen pH gets out of hand or goes beyond a threshold, then disease will occur, okay? Not in terms of disease per se, but inflammation and changes in the immune function will take place. Basically, what happens is that when some of these bacteria die, like gram-negative bacteria, they will some fragments of their bacterial wall will be exposed, like lipopolysaccharides. These lipopolysaccharides are powerful immune stimulator. They actually promote inflammation. And that's what you can see in this slide. We're comparing animals that are under normal conditions in rumen pH and animals under a SARA, subacute rumen acidosis. And you can see that actually there's an accumulation in both in the rumen and in the blood of the animal. So it has an effect locally on the rumen, but also an effect on the entire host of that concentration of LPS. What LPS or lipopolysaccharide will do is will trigger an inflammation response. And also, you can also see this in the slide. There is at two levels. First, at a transcription level, so there will be an expression of that inflammation interleukins. And not only the expression, but also they will be actually expressed. They will be transcribed into proteins, and that will elicit inflammation. When that happens, that has an energy and a protein cost for the animal. So we now have an animal that is an inflammatory status, driving away nutrients that otherwise would have been used for milk production or reproduction. Now they are being diverted to elicit an inflammatory response, that it's not going anywhere. Okay, so that's the first sign, or the first disease that we can have. It's a pre-pathological status, if you wish. There is also an actual pathological status, which is if the animals are exposed to rumen acidosis for a continuous period, or for an extended time of an extended amount of time, the rumen wall will become brittle and will become permeable to some bacteria. And then these bacteria will actually be able to penetrate the rumen wall and be transported through the portal vein into the liver. And then they will actually live in the liver, causing liver abscesses. And of course, ultimately, that will compromise the physiology of the animal, right? We think that the milk is produced in the udder, but actually milk is produced in the liver. And when these bacteria colonize the liver and cause liver abscesses, then we are minimizing the capacity of the animal to supply nutrients for the mammary gland to produce milk.
Okay, thank you. And what about external sign of rumen acidosis?
Yes, another good question, right? Something as important as rumen pH, when it goes out of whack or beyond some thresholds, of course, we're going to see signs in the animal. Perhaps the most common and evident sign would be a decrease in appetite. And as was mentioning before, right, when rumen pH goes down, there is a change in microbial population. Some bacteria die. Those bacteria will expose their contents into the rumen fluid. The concentration of those, or the accumulation of those solids or contents of the bacteria in the rumen fluid will lead to an increase in rumen osmolality. Whenever rumen osmolality increases above 340, 350 milliosmoles, there are receptors in the rumen wall that will detect that osmolality and will tell the cow that something is wrong in the rumen. So the cow will react to that with a decrease in appetite. So feed intake will go down. Now, this very easily said is more difficult to see in the field. In the field, what I actually like to see is the rear end of the animals, because not all the animals have the same rumen acidosis cycle. So they not always have rumen acidosis at the same time. So maybe the feed intake from the pen doesn't change, right? So we don't see a decrease in intake because one cow is very hungry and eats a lot, and the other one has rumen acidosis and doesn't eat, and they compensate. However, you can see what happens in the rear of the animal, because when an animal has rumen acidosis, digestion in the rumen goes down. That means that there is a greater flux of fiber into the hindgut. Fiber attracts water, and feces become more watery. So it's some sort of a diarrhea. So what you'll see is that when you have a rumen acidosis episode, you will have a bunch of cows with dirty tails and wet. That means they're having diarrhea. And some other cows that will have dirty tails, but they are dry, meaning that they had an episode of diarrhea and therefore acidosis a few days before or a few hours before, okay? So that's a very good sign to look at. The other good sign to look at is related to intake. When animals feel that something is not going well and they lose appetite, they will consume less feed and they will ruminate less, okay? Be careful with that though, because this will be very evident when the cows are under acute rumen acidosis. But when they have like subacute rumen acidosis, which is the most common one, what we actually will see in the field is that if we use rumination sensors, for instance, to our surprise, the cows that have rumen acidosis will be most likely the cows that ruminate the most, which initially doesn't make sense, right? But if we think about it, it makes all the sense of the world. These are two different studies showing the same thing. Cows that eat, that ruminate the most are the ones that have the lowest rumen pH. Why is that? Well, because the cows that actually have rumen acidosis are those that have consumed a lot of feed. And that consumption of feed is actually what drives the rumen acidosis. So if the cows eat a lot, they will ruminate a lot. So to make sense out of rumination time, we need to look at, okay, how many minutes the animal is ruminating over how many feet or how many kilos of dry matter the animal consumed. Only just looking at time is not going to do the trick. And then there is another sign of rumen acidosis that you can look at it, which is milk fat. But it's not very specific of rumen acidosis. You could have low butter fat in milk by rumen acidosis, but also by feeding some types of fats in the diet or some other problems with rumen fermentation. So maybe the most important one, the one that I look in the field, very, very easy to spot, is dirty tails and these episodes of diarrhea.
Okay, thank you for these elements. Let's talk about your 2017 study. Can you tell us how it was designed?
Yes, back in 2017, we did an interesting study looking at, that was published in Journal of Dairy Science that year. What we did is we involved a group of cows, I think it was 30 animals, and what we tried to do was inducing rumen acidosis. And of course, sometimes it's difficult because, as I said before, the cows will have some mechanisms to counteract that rumen acidosis. They will adapt to that diet. They will stop eating. So they will do all kinds of things. So the setting that we chose to do was, okay, we'll start with a normal ration. And we start with a ration that was 40% forage and about 20% barley. And we use barley as the elicitor of rumen acidosis. Barley ferments really rapidly in the rumen, generates lots of acid. So it's a very good ingredient to provoke or induce rumen acidosis. So we kept the cows on that diet for a while, and then a week later, we remove a fraction of forage. So we reduce from 40 to 32% forage, and we increase barley. We expose the cows 7 days to that diet, and then 7 days later, another decrease in forage and an increase in barley. And then a fourth week, we also decrease forage and increase barley. So we went from a ration that was 40% forage, 20% barley, to a ration that was 27 forage, 32% barley. And these cows were separated in 3 groups. We had a control, that was a negative control without sodium bicarbonate or magnesium oxide. Then we had a treatment group that was sodium bicarbonate at around 1% of the dry matter. And then we had a group that received no sodium bicarbonate, but pHix-up. And that was the setting.
And what were the main results regarding ruminal pH?
Okay, yes. So the main results for the ruminal pH was, the first one was, okay, the model that we use to induce rumen acidosis works. And as you can see in the slide next to me, if you look at the CTR means control, so that's the negative control. And then you see different bars with different colors. The darker the bar, the more intensive the rumen acidosis is. And you can actually see that, yes, rumen pH goes down as we increase barley and remove forage in the diet. But the other interesting thing is that when we fed sodium bicarbonate, we also saw pretty much the same decrease in rumen pH as in control. Okay, and the way we measure rumen pH was with rumen boluses. So these cows had rumen boluses, and we were measuring rumen pH every 15 minutes. More interestingly, when we fed pHix-up, of course, there was also a decrease in rumen pH because the strategy of causing rumen acidosis worked and it was severe, but it did not decrease as much as with the negative control cows or with cows receiving sodium bicarbonate. In both average rumen pH throughout the day or the proportion of time or the number of hours that the animals were below a pH of 5.8. So if we look at these slides, cows on the control, negative control, they had about 80% of their time with a rumen pH below 5.8, and not 80, sorry, 50. And cows on pHix-up, they only were like about 30% of the time with rumen pH below 5.8, which is considered the pH threshold that is going to make the rumen really become unstable. Interestingly, cows on sodium bicarbonate, they spend more than 45% of the time also with a low rumen pH, below 5.8.
Okay, interesting. And what were your observations regarding dietary cation-anion difference, DCAD, that we know can have an impact on the production?
Yes, we thought about that a lot when we were designing the experiment, because of course we had a diet that had no sodium bicarbonate, and then one diet that had pHix-up or a blend of magnesium oxide products, and then sodium bicarbonate. So we know that the DCAD will be different. So the dietary cation-anion difference will be not the same between the three treatments. How much different it was, you can see it in this slide. So basically there was an increase of about 20 milliequivalents per 100 grams when we fed sodium bicarbonate than when we did not. So the control diet and the pHix-up diet more or less had the same DCAT, and then when we added sodium bicarbonate, the DCAT increased. There is a belief in the literature and in the field that very positive DCAT is also positive for intake and meal production. And that's a belief that is sustained by literature and evidence. But at the range that we're looking at, so the range in DCAT in the 3 diets that we fed, the lowest was 200 milliequivalents per kilo, or 20 milliequivalents per 100 grams. And the highest was 360, okay? So we're moving between 200 and 350. And within that range, as you can see in this slide also on my site, it doesn't really have an effect on intake or meal yield, okay? And in fact, there is a lot of variation, and the variation that we see in meal yield is actually greater than the variation that we see in DCAT whenever we move between 200 all the way to 500 DCAT in the diet. So after looking at the results and also thinking about the study, we can really conclude that whenever the DCAT in the diet is above 220 milliequivalents per kilo, there will be no further positive effects on intake and meal production. So that's basically the consequence. We should not be worried about, okay, what happens if my DCAT goes down from 300 to 270 if I remove sodium bicarbonate and I use pHix-up, or if I reduce a little bit sodium bicarbonate and do other changes. Within that range, meal performance and intake will not be affected.
So you just did a second trial with pHix-up this year. Do you have any new results that you could already share with us?
Yes, we just finished the study, so we're still processing the data and analyzing the data. I can show you just one glitch of it. This that you can see in this slide. This is rumen pH throughout the day. And in the study that we just finished, we used 4 treatments instead of 3 as the previous one. So we included a positive control. So we had a negative control as the same, so nothing, no sodium bicarbonate, no magnesium oxide. That's the red line in the slide that you see. Then we had a positive control that was sodium bicarbonate and about 60 grams of magnesium oxide. And that's the green line. And then we had 2 more treatments involving only pHix-up without sodium bicarbonate, one at 60 grams, that's the blue line, and another one at 160 grams, which is the yellowish line. Basically what we saw, and this is the average of all the cows in the treatments throughout the day, that the cows on 60 grams of pHix-up had a greater rumen pH post-feeding, followed by control, and then below the control we had 160 grams of pHix-up, and then the lowest was sodium bicarbonate plus magnesium oxide. Does that mean that 160 grams of pHix-up works worse than 60 grams of pHix-up? Not really, okay, because we also have to look at intake, as I said before. The reason why the control cows have actually greater rumen pH than cows on sodium bicarbonate or 160 grams of pHix-up is because these 2 later groups were actually eating more feed, because the rumens were a bit healthier and coping better with the acidosis than the cows that were without sodium bicarbonate or magnesium oxide or pHix-up. So we'll have more data later on. In terms of production, I don't think we're going to see significant differences. In terms of butter fat, I think we will reach significant differences, but we'll still need to analyze the data and look and see what they tell us.
Okay, very, very interesting. Thank you very much, Dr. Alex Bach. So now let's welcome our next guest. So for this second discussion, we are very happy to welcome Professor Marcos Neves. Hello, Professor. How are you?
Hi, how are you? Thanks for listening and to be here for the discussion.
Thank you. So, Professor Neves, you are an associate professor at the zootechnical department at Federal University of Lavras in Brazil, and you work especially on dairy nutrition and its impact on the production. So, since April 2021, you have been conducted a study on the impact of pHix-up on the ruminal pH. So, of course, the first results are preliminary, but can you give us a first insight of the study? So maybe my first question for you will be, what was the objective of your work, including pHix-up?
Yeah, our idea was to evaluate pHix-up against sodium bicarbonate, 0.5% of pHix-up against 1% of dry matter of sodium bicarb. And we use a Latin square trial, so it's a short-term response. And we evaluate lactation performance, intake, the milk fatty acid profile that can explain the milk fat response. We also did total tract digestibility of nutrients. We evaluated rumen pH and fermentation profile, eating and rumination behaviors. And we got some measures of systemic acidosis, just evaluating blood gases and pH of the jugular blood. That's basically our goal.
Okay, thank you. Very clear about the objectives. What was the design of the study?
Yeah, we used the Latin square design, as I said, like with 21-day periods and 14 days of adaptation. And so we considered that like our response before the start challenge was from days 14 to 17. On day 17, we started to simulate a big farm mistakes. Let's put it this way. For example, we removed food from the cows at 10 p.m. on day 17. And on the next day, we abruptly increased the starch content of the diet by replacing citrus pulp with high moisture corn. And we did it for 4 days. So it's a kind of a big mistake of a farm that doesn't feed enough of the cows in one day, and the next day makes a big mistake on mixing the diet. So the starch content really went up, and we kept it high for 4 days. So we had measurements before the starch challenge and during the starch challenge. And that's how we did it.
Thank you, Professor, for your explanation. So I understood you replaced the citrus pulp by inside maize corn grain. So can you tell us more about the diet?
I think that was our option to our protocol. So we kept forage the same, protein sources the same, whole cottonseed the same, and we just changed the citrus pulp for high moisture corn, an abrupt change. So starch content of the diet went from about 22 to about 32. So we got an increase of 10 percentage units of starch of a cow that did not have enough feed the day before. So just to show how effective it was, like the acetate to propionate ratio in the rumen, it went from 3.7 to 2.7 roughly. So it's a big change, a short-term change. And magnesium was higher on the pHix-up diet as expected, and sodium was higher on the bicarb diet also. But the big change is on the starch content. We changed the nature of the concentrate.
Okay. Yeah, very clear about the challenge of the diet and the methodology of the study. So now regarding the results, what were your observations regarding the effect of pHix-up on the ruminal pH?
For rumen pH, we use the probes, these MaxTech probes. So we have like a rumen pH over the 24-hour period. I think it was very interesting to understand like how low the pH goes on the first day of the start challenge. The only day we had a pH below 6 was on day 18. And we did it 4 days. The pH curve is nice to understand also. When you have the minimum, it's about 10, 12 hours post-feeding. So, and it's a normal curve for a dairy cow on a TMR, a total mixed ration. Cows were fed once per day. Okay.
Okay.
So the results on minimum, we got some results on minimum pH. Okay, so pHix-up increased the minimum pH on day 20 and on day 21. Okay, and pHix-up also reduced the time, minutes per day of pH below 6.2. Like we use 6.2 as a threshold in this case. So showing that pHix-up was even more effective than bicarb in keeping pH high. But the effect, the major effect was on the minimum pH of the day, more than the maximum pH, like mean pH, but was really effective in controlling it, I think.
Okay, and what were your observations regarding the effect of pHix-up on the intake?
Yeah, the intake was really a very interesting response in this experiment. We got an interaction between treatment and day of the start challenge. If you see like bicarb, it increased intake on day 19, and by day 21, both pHix-up and bicarb, they both increased intake relative to the control. Okay, so like if the pHix-up was a little bit later the intake, but on average, both rumen neutralizers increased intake at the end of the start challenge. Okay, so I think what was very interesting. And when you look at the blood data, I don't know if you have it there, the blood pH and the blood pressure of CO2 in blood. I think it's probably explained this kind of response. Like blood pH doesn't change, but when you add cations like magnesium and sodium, like cause they retain CO2 to keep the pH at the same level. So you don't see an effect on pH, but you see an effect on the amount of bicarb in blood. So actually you increase blood buffering capacity, and I think it may be a mechanism why those sources of cations, both bicarb and magnesium oxide, the pHix-up in this case, they both increased pH, and it's probably a very fast acting mechanism. Okay, you're not affecting only rumen pH, but you're affecting systemic acidosis and the capacity of the cow of buffering acids and buffering NIFAs. So I think it may be a reasonable explanation for the response in intake, at least in my interpretation.
Okay, so yeah, very interesting about the intake and the blood pressure. Very interesting elements. And what did you observe on the rumination behavior of the cow linked to the digestion?
Yeah, that was very interesting also. Like we had never used the probes before, the rumen probes. And in this experiment, we had the probes to measure ruminations on the neck of the cows. And we did ruminations by visual observations also every 5 minutes of the day for 24 hours. And this is just the data of the sensors that I'm showing there. The results were the same actually for the sensor and for the visual. And cows on control without the rumen neutralizers, it seems that they required more rumination to keep the same or the same rumen pH. When we get rumination divided by rumen pH, control was much higher, and the lowest value was for pHix-up. I had never seen that number before, and I think it was really nice. Like cows on control, and that's interesting because we measured NDF digestibility, and it did not change. For example, cows on control, if the digestibility of the NDF was lower, they would ruminate more, but the digestibility did not change. So it looked like the cow is reading the pH of the rumen, is ruminating more if she needs. And I think it was a kind of a neat result. Very first time I saw it in reality. And yeah. So like they required less rumination to buffer the rumen.
So yeah, very interesting. So everything is definitely linked together. And so, what are your observations also regarding the effect of pHix-up on milk fat and on the milk fatty acids profile?
Yeah, that was really another very interesting result for us, right? And the main performance response that we got was an increase in milk fat. It went from 365 to 380, okay? And the interesting thing that we got an increase in preformed fatty acids and in oleic fatty acids and in unsaturated fatty acids. So these long chain fatty acids like these preformed fatty acids are the ones with more than 16 carbons. And they come from the diet or they come from the adipose tissue. But those cows were not mobilizing adipose tissue because they were mid to late lactation cows. So it's probably coming from the diet. Okay, so we got an increase in ETA extract digestibility, a measure of fat digestibility. So it looks like that pHix-up increased fat digestibility and these long chain fatty acids were incorporated by the mammary gland, and this explained the increase in milk fat. It was unexpected to us because we were expecting an increase in de novo fatty acids, the ones that the mammary gland makes. And usually when you control acidosis, the de novo, sometimes they can increase, but we got an increase in preformed, suggesting that pHix-up increased fat digestibility. In my interpretation, may have favored the formation of magnesium soaps in the rumen, so it may have avoided the saturation of the unsaturated fatty acids in the rumen, so we got more unsaturated fatty acids going to the lower tract, and it's known for many years that unsaturated fatty acids have higher digestibility than saturated fatty acids. So it's a different mode of action, and it's very, very interesting. Like we would like to run trials with very high fat diets. Probably the effect may be even higher. We had some whole cotton seeds in our diet, but the diet was about 5% ETA extract only, not an extremely high fat diet. But I think the mode of action for the increase in milk fat was totally new for us, and I think it was very interesting and show another potential of pHix-up, that's to increase fat digestibility. We had similar values here with beef animals. pHix-up increased subcutaneous fat in another trial by a colleague in my department, Mateus there. And I think it's a new avenue for so it can control acidosis and it can also increase lipid digestibility. We also had an increase probably in the pH of the duodenum, maybe related to the response, but we don't know exactly. But I think the fatty acid profile tells a nice story on why the milk fat is increasing. It's just not, if we did not have that, we would never know like why the increase happened. And I think it's neat.
Yeah, very interesting elements and maybe new topics to study. So maybe we can also talk about the fecal pH. I know you mentioned that. Can you tell us a bit more about your observation on that specific topic?
I think it was very interesting also because like what happens, like the bicarb, it buffers the rumen, but it basically disappears there. And the pHix-up, the magnesium oxide in this case, it keeps buffering the entire digestive tract. And you can measure like a very expressive increase in fecal pH when you use pHix-up. Okay, for example, when we induced acidosis, the fecal pH went down as expected. You had more starch going to the lower tract, so you have more fermentation in the lower tract of the cow. But I think so it tells us that it's buffering the entire tract. And for example, we could increase the action of amylase at the duodenum, although we did not get an increase in starch digestibility in this experiment, but it could be plausible to happen. But yeah, I think the nice thing about the pH, you can probably use you to modulate the dosage of pHix-up in a farm. For example, you can give it a specific dosage if you define like I want that pH increase and maybe useful in the field. Okay? But I think it shows that the mineral is basically buffering. It's an alkalizer for the whole digestive tract, not only for the rumen. And it's a different mode of action when you think only about rumen buffer. It's not just a rumen buffer. It's buffering. So, for example, it may affect like tight junctions in the intestine, but we still don't have data on that, but it's feasible, and you can probably affect like intestinal health. You can affect the action of amylase, and has field application, as I said. Like you can use it probably to define your dosage, if it's being effective or not, because it's very easy to be measured. Like you can go to any farm and measure fecal pH. And it's very difficult to get results on fecal pH. And we got really nice results. The increase was substantial. We got p-values on that. And I think was really interesting and maybe useful, I think.
Yeah, okay. Thank you very much. So maybe new indicators coming for pHix-up. Thank you very much, Professor Marcos Neves, for your expertise and for the study and the insight of these very interesting results. Thank you again. And so now let's move on to our next guest. So let's now have a practical approach with the testimony of our new guest, Dr. Javier Viejo. Hi, Javier. Welcome and thank you so much for joining us today.
Buenas tardes, Ogor. Buenas tardes a todos los compañeros que estáis ahí y buenos días a los que estáis en América.
Thank you, Javier. So you are a technician veterinarian for Tecnivet in Spain. So here is my first question for you. In a few words, can you describe your activity?
Sí, bueno, como veterinario en vacas de leche llevo trabajando desde el año 1983. Actualmente trabajo en 6 granjas en la provincia de Sevilla, 6 granjas de vacas lecheras con un total de 2.500 vacas en producción. Y en esta granja pues desarrollo el tema reproductivo, la nutrición, asesoramiento, así como cirugía en los días que tengo mis visitas programadas. Estas granjas tienen una media de producción a 305 días que va entre 10.200 y 11.700 litros. La calidad de esa leche, pues bueno, Andalucía, si conocéis un poco esto, aquí las temperaturas en verano suben muchísimo y la media aproximada anual de grasas estaría en torno a 3,65 y de proteínas en torno a 3,4. Y los consumos medios durante el año también está, el consumo medio de materia seca está entre 24 y 26 kilos por vaca y día. Aparte del trabajo en estas granjas, también comparto mi tiempo con la empresa de nutrición que es este Nutrition, donde soy el coordinador de rumiantes en general y de vacunos de leche en particular.
Thank you, Javier. You have been using pHix-up for more than 2 years now on some farms. So what brought you to use pHix-up?
A principios del año 2019, por parte de Timab Magnesium, nos ofrecieron bastante información sobre el producto y era una información bastante estudiada, comprobada, tanto a nivel de estudios in vitro como de estudios in vivo en distintas granjas de vacuno lechero. Desde los años 90 aproximadamente no había estudios que digamos, nos dijeran como nuevos productos de controlar pH a nivel ruminal. Y lo primero que me convenció de esta información que proporcionó Timab fueron los datos del poder de neutralización del pH ruminal comparándolo con otras sustancias, tampones y alcalinizantes. A su vez, también la rapidez y la persistencia de acción de este producto, incluso más allá de las 6 horas de haber aportado la comida. Otra cosa que también me interesó mucho fue el aporte de magnesio por parte de pHix-up, con una alta solubilidad en torno al 95% y una alta absorción también a nivel ruminal. Con todos estos estudios, que además estaban validados por INRA, Innovalis, Granja Blanca y en otras granjas tanto de España, Italia, Chile, Estados Unidos, etcétera, empezamos a utilizar pHix-up aproximadamente mayo de 2019, o sea, unos 2 o 3 meses después de que esta información por parte de Timab. Y 6 meses después de todo esto, también comenzamos a utilizar pHix-up en granjas de ternero de cebo y más tarde en ovejas y cabras de actitud lechera.
Why do you prefer pHix-up instead of sodium bicarbonate?
Bueno, en principio por la capacidad de neutralización que comentaba antes, que esta capacidad de neutralización es 3.25 veces superior de pHix-up sobre el bicarbonato de sodio. A su vez es 2.6 veces superior a la de óxido de magnesio, aunque aquí, bueno, se ha hecho una media de óxido de magnesio porque hay tanta variabilidad de óxido de magnesio en el mercado que se estimuló a hacer una media, entonces decir que el pHix-up es 2.6 veces superior al óxido de magnesio. Y en cuanto al carbonato de potasio, pues es 1.95 veces superior en cuanto a su capacidad de neutralización. Para los que estáis aquí de Sudamérica, hay otro producto que es el sesquicarbonato, que se utiliza también bastante por allí, y con respecto al sesquicarbonato, el pHix-up 3 veces superior su capacidad de neutralización. También, como comentaba antes, pues la acción rápida que tenía a nivel ruminal y la persistencia para el reparto de comida. Por supuesto, el aporte de magnesio, ya que el magnesio ni se genera en el animal ni se acumula tampoco. Entonces, debemos, digamos, hacer unos aportes diarios de magnesio. También su acción con cuando el pH ruminal está por debajo de 5.8 o por encima de 6. O sea que con un pH alto y bajo tiene los dos sentidos. Funciona tanto a pH bajo como a pH alto. También el espacio libre que nos puede quedar en la fórmula que estamos haciendo o utilizando. Y, por supuesto, dependiendo de los precios de mercado de los otros productos, el ahorro económico que supone la sustitución, sobre todo de bicarbonato sódico y óxido de magnesio. Y, claro, que hasta ahora no he hablado de nada de eso, el control que se puede ejercer sobre que tengamos una aparición de su acidosis dentro de nuestros animales, o sea, lo que llamamos SARA.
Okay, very interesting. So you included pHix-up in the ration. What is your feedback now on the field?
Sí, cuando empezamos a incluir el pHix-up en las raciones, lo primero que tuvimos en cuenta fue la capacidad de neutralización del pHix-up con respecto a los otros aditivos. Entonces, era más que nada hacer una cuenta matemática. Si, por ejemplo, aportábamos en España, en Europa, en Norteamérica, es muy típico utilizar sobre todo la asociación de bicarbonato sódico con óxido de magnesio. Entonces, pues hacíamos una sustitución de tantos gramos de aporte de bicarbonato sódico dividido entre 3,25 nos daba la cantidad de pHix-up a utilizar. Más si se utilizaba también una cantidad de óxido de magnesio, eso lo dividíamos entre 2,6 y nos daba también la cantidad de pHix-up a utilizar. Entonces, sumando estas dos cifras, pues nos daba aproximadamente la cantidad exacta de pHix-up a utilizar. Así empezamos. Posteriormente, también teniendo en cuenta las características de cada ración, pues empezamos un poco a, digamos, a normalizar los aportes de pHix-up. Entonces, cuando las vacas comían aproximadamente 24 kilos de materia seca, normalizamos de aportar entre 80 y 90 gramos de pHix-up por vaca y día. Para 25 kilos de materia seca, pues incrementamos aproximadamente 10 gramos en los animales hasta 100 gramos. Para 26 kilos de materia seca que comían las vacas, pues ya nos íbamos a unas dosis entre 100 y 120 gramos por vaca y día. Siempre teniendo en cuenta también que cuando retiramos, por ejemplo, el bicarbonato sódico de la fórmula, pues digamos, teníamos una bajada de aporte de sodio para los animales. Y entonces, bueno, estuvimos estudiando el tema y llegamos a la conclusión de recomendar una cantidad total de sal, de cloruro sódico, de entre 100 y 120 gramos por vaca y día, en el total de la ración. También tener en cuenta que, por ejemplo, en ciertas regiones de Sudamérica y de Europa, pues hay animales que pastorean. Entonces, para estos animales, los aportes de pHix-up deberían ser un poco inferiores, dependiendo también de la cantidad de forrajes que ingirían esas vacas.
So thank you for this feedback, Javier. So is it a product easy to use on dairy farms?
Es un producto que permite sustituir 2 o más ingredientes o aditivos dentro de la ración. Aunque estos aditivos a veces están mezclados previamente en núcleos que llevan incluidos los macrominerales, vitaminas, etcétera. El pHix-up es muy fácil de aplicar, o sea, es un polvo fino, pero muy fácil de manejar y además se aporta en una cantidad considerable por animal. Estamos hablando entre 80 y 120 gramos. Entonces lo podemos utilizar directamente en el TMR o incluso también, digamos, incluyéndolo en el TMR, pues mezclado con cualquier cereal, por ejemplo, el maíz. O sea que es muy fácil de utilizar.
Okay, so what other additive did you manage to replace thanks to pHix-up?
Bueno, en Europa, sobre todo, se sustituyó por en bicarbonato sódico y óxido de magnesio. En otros casos donde se utilizaban otro tipo de alcalinizantes, como por ejemplo el carbonato de potasio, de origen marino, pues eso también fue sustituido de forma radical. O sea, fue cambiar unos por otros y con un poco haciendo las cuentas matemáticas que expliqué en la pregunta número 3. Y otros productos que hemos sustituido, sobre todo ha sido el ácido palmítico, que ha sido muy utilizado en España, por ejemplo, para incrementar o subir el porcentaje de grasa en leche. Yo personalmente y algún compañero más empezamos a disminuir el aporte de ácido palmítico a la mitad y actualmente lo eliminamos completamente. Solamente con el pHix-up no teníamos bajada de grasa en leche.
Okay, Javier, so with the amount of sodium bicarbonate you reduced, what is the volume of free space you managed to create?
Bien, pues el espacio libre que nos pueda quedar pues depende de los otros tampones alcalizantes que estemos utilizando en fórmula. Una fórmula típica aquí en Europa o en España, que pueden ser aporte de 230 gramos de bicarbonato sódico más 50 gramos de óxido de magnesio, esto haría un total de 280 gramos. Haciendo los cálculos, pues esos 280 gramos con 85 gramos de pHix-up tendríamos suficiente, o sea que en este caso nos quedarían 195 gramos libres en la fórmula.
Okay, and for you and for the farmer, what are the benefits of using pHix-up in terms of animal performances?
Aquí hay muchos puntos esperados que puedan beneficiar. En primer lugar, pues deberemos esperar una mejora en la producción diaria, así como en la persistencia en leche. Debemos esperar un aumento de la grasa en leche. Debemos esperar también una mejora en la digestibilidad de la fibra y almidones. Puedo decir que estamos utilizando raciones con un 34 o 35% de almidones, no solamente gracias al pHix-up, va muy bien, pero sí que ayuda mucho a trabajar con unas porcentajes altos, por ejemplo, de almidones. También nos hace una concentración óptima de magnesio en sangre durante el periparto y todo el periodo de lactación. Esto nos traerá como consecuencia, pues eso, una disminución tanto de hipocalcemias como hipomagnesemias. O podemos tener, hay algunos estudios sobre ello, una mejora en fertilidad. Por supuesto, ya está muy comprobado que tenemos un efecto positivo en cojeras, sobre todo a nivel de pezuñas y de pododermo. Las laminitis prácticamente desaparecen y bueno, y es probable que también mecanismos similares a los que pueden tener respuestas inflamatorias cuando aparece el SARA, pues también median en el daño del casco. O sea, también nos previene la bajada de ingesta del alimento y, por supuesto, la producción de leche, claro. También, si mantenemos un pH estable dentro del rumen, por encima de 5,8, mejoramos la funcionalidad del rumen y las consecuencias que tiene también a nivel intestinal, evitando patologías en órganos y tejidos como hígado y pezuña. O sea, si tenemos el rumen estable, tenemos el rumen sano, la vaca va a estar mucho más sana. Y ya también comenté antes que también por su alta solubilidad, que hasta un 95% del magnesio aportado por pHix-up se solubiliza en el rumen y es absorbible por el animal.
Okay, Javier. And is pHix-up useful during the hot summers in Andalusia to help to maintain the percentage of fat in the milk?
Bueno, en cuanto a eso, pues ya hemos pasado 2 veranos. Comenzamos a principio de verano del 19 en varias granjas, tanto del centro como del sur de España. Actualmente estamos por toda la península y en Sudamérica bastante también. Y en los 2 veranos que han pasado no hemos notado ninguna bajada en ingesta de materia seca, ni en producción de leche, ni bajada de grasa en leche, comparándola, claro, con otros veranos anteriores. Estamos también haciendo estudios para ver digamos, los efectos del estrés por calor con respecto a pHix-up.
And Javier, what about the welfare of the animal? What did you observe on the dairy cow's hooves?
Sí, bueno, en cuanto a los pies hemos observado cosas, pero permíteme que te comente que lo que sí es una imagen, digamos, patognomónica cuando empiezas con pHix-up es que a las 48 horas todos los animales prácticamente se homogenizan el estado de las heces. O sea, tienen por ahí, además en los slides que mandé, se ve perfectamente. Claro, aparentemente se hace una mejor digestión de la fibra. De hecho, el magnesio es un cofactor de las enzimas fibrolíticas y eso se nota rápido, en 2 días. Decimos que las heces son como el alma de la vaca. Si las heces están bien, homogéneas, eso quiere decir que la vaca está bien. Cuando en una granja observas, que yo personalmente cuando voy a una granja lo primero que observo son las heces de los animales y ves diferentes consistencias en las heces, unas aparentemente bien digeridas, otras con una diarrea líquida, otra diarrea pastosa, y eso lo que me viene a decir es que en esa granja algo no va bien. El pH ruminal adecuado favorece otra serie de cosas a nivel de las bacterias ruminales, del epitelio ruminal, de epitelio intestinal, hígado, y con respecto al comportamiento de los animales, con el aporte de pHix-up, lo que sí se nota es que las vacas están más tranquilas, que descansan, comen, dan leche, que es en definitiva lo que buscamos en la granja de leche.
And Javier, did you observe a reduction of lameness on the cows?
Los efectos sobre la pezuña, sobre la uña y el pododermo de las vacas se observan a lo largo de, o sea, no es tan rápido, pero a partir de 45 o 60 días se empiezan a observar. Yo, de hecho, tenía también, era una de las cosas que al principio me hizo pensar que pHix-up podía funcionar bien para esto. Y la verdad que esto se confirmó más tarde cuando se empezaron a hacer revisiones de podología en las granjas. Algún podólogo me llamó a sus potros y me dijo, mira esto. Digo, yo no estoy sorprendido. Y tú me dices, sí, yo estoy sorprendido porque no he visto pezuñas así. O sea, la aminitis desaparece, todo lo que es pudredumbre de casco desaparece. Por supuesto, la dermatitis no, eso es infeccioso, pero todo lo que es a nivel de uñas se mantiene muy bien, muy bien.
Okay, Javier. So you also made some magnesium analysis in blood samples. What is your feedback about that point?
Sí, entre finales del 19 y principios del 2020, en 2 granjas hice 3 lotes en cada granja de 5 animales cada lote. O sea, un lote sería en preparto, o sea, 22 días antes del parto previsto hasta el momento del parto. Otro lote sería de 7 a 20 días posparto y otro lote ya con lactación bastante avanzada que podía ser, pues eso, entre 150 y 300 días posparto. Y tomé en todas ellas muestras de sangre y los resultados fueron con unos niveles bastante aceptables que iban entre 2,1 y 2,4 miligramos por decilitro de magnesio en sangre. Y también esto mismo lo hice más adelante, y por ejemplo en una granja de cabras, y aquí obtuvimos entre 2,5 y 3,2. Estas cabras estaban todas entre 60 y 120 días de leche. En cuanto a hipocalcemias, pues también se bajó mucho viendo los niveles de magnesio. Y claro, hay que tener en cuenta que el magnesio aumenta la concentración de calcio en plasma. Luego, a nivel de periparto, podemos evitar bastantes patologías, tanto primarias como secundarias.
Okay, Javier, and I think you made some analysis on the pH in feces and urine. What did you observe?
Sí, el año pasado, 2020, hubo una interesante discusión con referencia a la bajada teórica del DCAD cuando se introdució a pHix-up en las raciones y se sustituía el bicarbonato sódico, por ejemplo, ¿no? Creo que esto el Dr Alex Bach hablará sobre ello, yo no comentaré nada más, pero nada de lo que se suponía que teóricamente podía producir en los animales, como una bajada en la ingestión de comida o una bajada en la producción de leche y de grasa en leche, nada de eso hemos tenido ni hemos notado en los animales que teníamos el pHix-up introducido y por ejemplo, el bicarbonato sódico eliminado. Dentro de todo esto, un punto a analizar que nos va a evaluar de una manera muy consistente el estado ácido-base de los rumiantes, digamos el DCAD, es una medición del pH urinario. Cosa que yo he estado haciendo, pues eso, a nivel desde hace prácticamente un año. Estamos mirando el pH urinario y también el pH fecal, porque también puede ser este pH fecal un indicativo directo de las acidosis a nivel digestivo o intestinal. Entonces, cuando comencé a hacer estos muestreos, utilicé 2 tipos de pHímetros, uno para líquidos y otro para lodos sólidos. Estas mediciones las hice empecé con vacas y últimamente también lo he hecho en cabras lecheras. En vacas en heces alimentadas con pHix-up, el rango del pH estaba entre 6,3 y 6,7 y el de orina estaba entre 7,8 y 8,2. A punto que en vacas lecheras debíamos tener un pH de orina igual o superior a 7,70. O sea que digamos que no había un pH bajo en orina, lo que nos podía indicar que no había ningún problema del estado ácido básico del animal. Y en cabras estas mismas mediciones dieron una media en heces de entre 6,7 y 6,9 y en orina entre 7.85 y 7.9. Aquí en estas mediciones de cabras, aquí ya teníamos unos lotes hechos y no había ninguna diferencia entre el lote que estaba alimentado con una mezcla de bicarbonato sódico y óxido de magnesio con referencia al pHix-up. O sea, las mediciones del pH urinario era prácticamente lo mismo. Luego se supone que el estado ácido básico de esos animales estaba en las mismas condiciones.
Thank you very much, Javier, for this very interesting feedback and testimony from the field. Thank you. Muchas gracias.
Muchas gracias a vosotros.
So we had such interesting technical discussions today and testimonies from the field with pHix-up from our guest. So very, very much thank you to you. And Melody, I think it's time to wrap it up. So, Melody, according to you, what is important to remember today?
Yeah, it's important to remember that pHix-up has shown to be the most efficient solution to act on rumen pH. So this leads to an improvement in rumen environment and then feed efficiency, performances, and global condition of the animals. And also, pHix-up is a field-proven solution, improving the efficiency of the diet and bringing added value for farmers and for feed millers.
Thank you, Melody. And thank you all for your time with us today. We've been very pleased to have you and to spend this hour with you. Thank you for all your questions, and for the one we haven't answered yet, we'll be back to you shortly with some answers. Thank you again, and see you very soon.